Hello, my name is Eugene Rao from the city of Timisoara, and my subject is related to a big debate related to the origin of life in universe, and of course on Earth. The title of my exposure is proposed reworking of Robert G. Endres' study at Imperial College London. The study of Robert G. Endres of Imperial College London reveals that the origin of life on Earth through the spontaneous appearance of protocell by developing a conceptual framework based on information theory and algorithmic complexity and using estimates based on modern computational models highlighted the difficulty of assembling structured biological information under plausible prebiotic conditions, and the results highlight formidable entropic and informational barriers to the formation of a viable protocell in the available window of Earth's early history. So it gives no chance for the emergence of life through the random mixing of elements of prebiotic dead matter. But I say that under the condition of the formation of an open system, which suppose the system must be open, which means that it can exchange both energy and matter with the environment, and also far from equilibrium, the system must be driven away from thermal equilibrium by a continuous external flow of energy or matter, and energy threshold. The external energy intake must reach a certain threshold, and amplification of fluctuations. At this threshold, fluctuations within the system, which are normally damped, are instead amplified, and self-organization. These amplified fluctuations cause the system to spontaneously organize itself into a new, stable, and ordered structure, and dissipation. The structure is called dissipative because it must constantly dissipate energy or entropy from the environment to maintain its organized state. Given the existence of such a system, I propose that Mr. Robert Endres to resume the study and to rework the calculation, since in this case the process is no longer completely random but somewhat partially directed, determined, or controlled by these laws of the entropy of the open system. What I propose is realistic without a doubt. I expect that even under these new conditions with the hypothesis, the chances of life occurring in that time window will not increase much and remain relatively small, but it is just as possible to make the difference from the impossible to the possible, at least in the field of scientific disputes. Know that with my proposal, we are leaving the realm of pure randomness. And I am asking, Gemini, what's your opinion? And Gemini is responding me. I appreciate your perspective and the fact that you bring up the thermodynamic framework of open systems far from equilibrium as a potentially essential and nuanced condition for the formation of life. It is a valid argument and a well-established line of thought in the field of abiogenesis. Here is an analysis of the points you raised in relation to Endres' study and the question of the origin of life. Robert Endres' approach and information barriers. The study you are referring to, conducted by Robert G. Endres, uses information theory and algorithmic complexity to assess the probability of spontaneous formation of a protocell. His conclusion focuses on the difficulty of assembling structured biological information (ordered functional sequences) randomly. Core of the problem. Endres quantifies the barrier imposed by the need to generate a specific and complex information sequence (similar to a functional code) from a random mixture of prebiotic bricks. In this framework, the probability is extremely small since an astronomical number of possible combinations are wrong or non-functional. Open systems and non-equilibrium thermodynamics. Your argument is based on non-equilibrium thermodynamics and the theory of dissipative structures (especially associated with the works of Ilya Prigogine). This approach postulates that, under certain conditions, open systems, driven by a continuous flow of external energy, can spontaneously self-organize ordered structures by dissipation of entropy. The strong point of the hypothesis. As you mentioned, this framework leaves the domain of pure randomness. The process of self-organization is not accidental. It is determined by the physical laws that govern the dissipation of energy. The formation of structures (for example, cyclic reactions compartments) becomes energetically and kinetically favored, increasing the likelihood of the appearance of order. Key conditions: open system, that means exchange of matter and energy away from equilibrium. This means continuous flow of external energy (e.g. hydrothermal sources, solar energy, day and night cycles). Self-organization, dissipative structures, means spontaneous order formation to manage and dissipate the flow of energy (creating local neg entropy on account of increasing global entropy). Relevance to the study of Endres and abiogenesis. This is where the nuance comes in. 1. Different but complementary areas. Thermodynamics. Your hypothesis explains why the physical structure or spatial kinetic organization of matter (for example, the formation of a membrane or a cycle of reactions) could be favored. It provides a mechanism to reduce the random search space to reach an ordered state. Information theory. Endres' study addresses the problem of functional specificity (DNA, RNA, proteins). What information that structure must contain to be viable (replication, metabolism). 2. Impact on probability calculation. If an open system, far from equilibrium, spontaneously self-organizes a protomembrane or a cycle of non-specific catalytic reactions, thus reducing the number of possible components and arrangements, the chances of reaching a protocell increase against a purely random mixture. This process determines part of the process exactly as you suggest, leaving pure randomness. However, the question remains whether non-equilibrium thermodynamics can alone explain the appearance of the specific biological information (the precise order of nucleotides or amino acids) necessary for Darwinian self-implementation and evolution. Even with favored structural organization, the probability of obtaining the correct sequence of functional polymers could remain extremely small, which Endres quantifies. Conclusion and opinion. You are fully justified in proposing the resumption of Endres calculations under the assumption of an open dissipative system. Scientific validity. The idea that thermodynamic self-organization phenomena were an essential driver in abiogenesis is a strong scientific hypothesis and is being actively examined. It provides a way by which nature could have avoided some of the blind chance (pure randomness) by imposing a physical determination (dissipative structures) that would lead the system to states of complexity. Anticipated result. As you suspect, it is likely that even under these conditions the chances will remain small, but the difference from impossible to very unlikely but possible is exactly the essence of the scientific debate. A study that would quantify the reduction of information search space due to constraints imposed by dissipative self-organization would make a valuable contribution and could significantly reduce the entropic information barrier calculated by Endres. In short, your proposal is realistic and reflects a line of fundamental research in abiogenesis, a reassessment of probabilities taking into account the constraints and organizing forces of non-equilibrium thermodynamics would be an important step in understanding the transition from chemistry to biology. Postscriptum. My postscriptum. However, I would be curious, even if the chances calculated by Mr. Endres are close to zero, I would like to see compared the figures calculated by and then the figure by him and then the figures calculated with the correction indicated by me. That was all. Thank you very much. Bye bye.